Alrighty, our last depreciation calculation method is what we call double declining balance. I'm going to reference it as DDB. Now, as you've noticed, each of our two previous depreciation calculation methods had a formula. This one does as well, and I want you to take note that this formula is going to be demonstrated in two parts. So the depreciation expense for DDB equals a depreciation rate, which will be a percentage, times the net book value. Okay? To get this depreciation rate, it's always going to equal the straight line rate times 2 times cost minus accumulated depreciation, which is the book value. So if you remember correctly, in our previous ones, it was cost minus salvage value. In DDB, no salvage value is taken into consideration to come up with the depreciation expense. However, you can never go below the salvage value anytime you do a depreciation calculation. So that will come into play when we're doing DBD. So now let's go ahead and take a look at a problem coming up with this straight line rate and what this looks like on the next slide. So in this case, we recall that Dozer's purchased a truck for $65,000, so that's the same. He has a salvage value of $15,000 and a 5-year life. The straight line rate is 1/5 because we were taking 5 years, or 20%. You would take 1 divided by 5 gives us 20%. So the double declining depreciation for 2012 would be 65,000 times 2 times the straight line rate. So that means that each year we're going to take the depreciation rate is 40%. So in this case it would equal 26,000. We would debit depreciation expense and credit accumulated depreciation. Every year we are going to take 40% of the net book value up to the salvage value. So let's see what that means. Go slide. So here it says there's, as it says here, several key issues to notice in DDB. It is applied to the net book value. So in this case you can see we have 40% times 65,000. Depreciation is 26,000. Our accumulated depreciation now is 26,000. So we subtract that from the original 65,000, leaving us with 39,000. You will see here that now we take this rate we calculated, the 40% times 39,000. That represents 65,000, which was the original cost, minus the accumulated depreciation of 26,000, leaves us with 39,000. Then the next year, and so then you come up with a depreciation expense of 15,600. Accumulated depreciation now is 41,600. The 26,000 from the first year plus the 15,600 from this year. We subtract that from the 65,000 and we get 23,400. That is our net book value after 2 years of depreciation. We come over here, we then multiply it times the rate, and we get 9,360 for this year's depreciation. See that the depreciation declines each year from the previous year. Hence the double declining balance nomenclature on this particular calculation method. So now the accumulated depreciation is 50,960. You can see that our net book value is 14,040 at this particular point. We said that we could never go below, right? We could never go below the $15,000, which was the salvage value. Therefore, we can only take, in this year where we wanted to take 93,360, we can only take 8,400, hence bringing us down to the 15,000, and at this point there would be no more depreciation because we can only go up to the salvage value. I know this might be a little confusing, but we're going to walk through an example. Well, I hope we will give you more clarity in a moment. In addition to this, it's again showing us that why some adjustment must be made in 2014, you can only make the 8,400. Also, you should notice, like I said previously, that this is a good picture of how the depreciation expense each year declines. It's always higher in the early years and less in the later years. This method is used very well for equipment that maybe in its later years doesn't work as efficiently. We know that a brand new car drives much better than a car that's 5, 6, or 7, 8 years old. And so we take that same premise to machinery. Now let's go ahead and turn to the exercises once again so we can take a look at this in a little bit more detail. So we are looking at page 207, and we're going to look at number 5. Number 5 says Sanders Catering purchases a van at a cost of $32,000. So we have a van worth $32,000. Its estimated salvage value at the end of its life is $6,000. It is driven, or it's expected to be driven, for 4 years. So that's its useful life, is 4 years. Garrett uses the DDB method, or double declining balance method, of depreciation. Calculate the depreciation expense for each of the 4 years of the asset's life. So let's go ahead and take a look at what that would look like. What I'd like to do at this point is go ahead and set it up so we'd have year 1, year 2, year 3, and year 4. We know by what they just told us we can never go below the salvage value. So we should keep that in mind as we go ahead and take a look at this. So the depreciation should be taken on 4 years. So if we wanted to do that and we would do the straight line, 1 divided by 4 gives us 25%, and the depreciation rate for DDB is always 2 times the straight line. That means that our depreciation rate each year is going to be 50%. So the formula is cost minus accumulated depreciation times the depreciation rate, or 2 times the straight line. So in this cost we would have $32,000 in the first year minus 0 because we don't have any accumulated depreciation yet, times 50%, which gives us $16,000. that would be our depreciation debit to depreciation expense, credit to accumulated depreciation. The net book value at this part would be the cost minus the depreciation. In this case would be $16,000. When we go down here, we would then do $32,000 minus the accumulated depreciation, so you can see what that is from the previous year, times 50%, which would give us $8,000. So this year the depreciation expense would be a debit to depreciation expense for $8,000 and a credit to accumulated depreciation for $8,000. In the previous year, that entry would have been $16,000. Now our net book value is $8,000. Okay? The third year depreciation would be, if we were to calculate this out, would be $32,000 minus $24,000, because now the accumulated depreciation is year 1 plus year 2 equals $24,000, times 50%, which in our case would equal more than what would be allowable. So in this case, this would be 8,000 times 50%, which would give us $4,000 of depreciation. But if we take 4 away from 8, we're going to end up with $4,000, and we know we can't go below 6. So what I like to do is put the 6 in once we know we can't go below, and our depreciation is what I'm going to call a plug, but the most depreciation we can take to keep us at not below the $6,000 is $2,000. And so you can never go below the salvage value. So the last year in DDB needs to be a calculated amount that is often, so a calculated amount often less than if you're using the rate, because it's a plug. Because I can only take that amount to get me to $6,000. And one of the other things I want to mention at this particular point is whether we do straight line, units of activity, or production, or DDB, the total depreciation on the same piece of equipment over time will be the same amount. It's just this way you're going to get it evenly over time. This way you're going to get it spread out, but totaling the same amount spread out over the useful life of the asset using units or hours, and DDB taking more in the first years and less in the second years. So no matter what depreciation method you choose for an asset, ultimately the same amount of depreciation will be depreciated in the same cases or under the same methods.